Next chapter, length. Now, length is the distance between any 2 points. We talk about length all the time, sometimes without realizing it. Road engineers will talk about the distance of the road to be tarmacked, maybe in kilometers or miles. Architects and construction engineers will talk about the heights of buildings and towers in feet or in meters. Diggers will talk about the depth of a pit or a well, again in feet or meters. The tailor will take the measurements for your outfits in inches. Athletes will talk about a 100 meters race. In mathematics, we talk about the perimeter of plane figures, and when it comes to circles, we call that perimeter the circumference. All these terms refer to the length of something. Different areas of profession have different units of measuring length, but the standard unit of length is meters. Small lengths, like in classrooms, are measured in centimeters and millimeters. Larger ones are measured in kilometers. Significant figures. Now, the significant figures of a number are digits that carry meaning contributing to its measurement resolution. When you have a number written, some of the digits are significant and some are not. Let's see the rules governing significant figures. First, all non-zero digits are significant. So 1,394, 15.61, and 2.441, all of these numbers have 4 significant figures. Zeros may or may not be significant depending on their location on the number. Let's see that in the next rules. Zeros in between non-zero digits are significant. 6,049 has 4 significant figures. 36.004 has 5 significant figures. 2.01201 has 6 significant figures. Next rule, leading zeros are not significant. That means the zeros that come before non-zero digits are not significant. 0.004 has 1 significant figure, only 4. 0.0102 has 3 significant figures because the 0 in between 1 and 2 is significant. Fourth rule, this is the most tricky one, but it's also simple when you see examples. Trailing zeros are sometimes significant and sometimes they are not. Let's look at these numbers. 400, 400.0, 5040, and 4050.000. Trailing zeros are those to the right of the first non-zero digit, counting from right to left. The thing is, if there is a decimal point, then they are significant. If there is no decimal, then they are not. And so for 400, there is no decimal. This number has only 1 significant figure, 4. For the number 400.0, we have the first non-zero digit 4, and all these are trailing zeros. In this case, there is a decimal, and so these zeros are significant. So here we have 4 significant figures. For the number 5040, 5 and 4 are obviously significant. This in between 0 is also significant. And then we have a trailing 0, no decimal, and therefore it's not significant. So here we have 3 significant figures. The last number, all these are trailing zeros. There is a decimal, and that means all these zeros are significant. And so here we have 7 significant figures. Next, rounding off numbers to a given number of significant figures. Now, when rounding off numbers to a given number of significant figures, we need to be careful so that we don't change the place values of the digits. This happens particularly when we have trailing zeros. The basic method is exactly the same as the method for rounding off numbers to a given number of decimal places. But there is an extra rule that you need sometimes. Here's the basic method. First, significant figures are counted from the left to the right. We first find the position of the last digit. That's where we want the last significant figure to be. And then you look at the next digit to the right. This is called the decider. If the decider is 5 or more, then we round up the last digit. But if it's 4 or less, we leave the last digit as it is. Now here's the extra rule for some significant figures. You need to fill in any gaps before the decimal point with zeros. Let's take a few examples. Write 3.48752 to one significant figure. We count significant figures from left to right. So the first significant figure is 3, and we only want one significant figure. So this is also the last digit. The decider is 4, and we can ignore everything else to the right. The decider is less than 5, and so we don't round up. Our answer is 3. Next example, write 0.0046854 to three significant figures. In this number, we have 3 leading zeros which are not significant. So the first significant number is 4. The third significant number is 8. This is our last digit. The decider is 5, and we ignore everything else to the right. The decider is 5, and so we round up the last digit, which means we add 1 to the last digit. And so the number becomes 0.00469 to three significant figures. Next example, round off 40,674 to two significant figures. The first significant figure is 4, and the second is 0 because it is in between digits. 0 is also the last digit. The decider is 6, and that is 5 or more. So we round up 0 up to 1. But that leaves us with 3 gaps before the decimal point. And this is where our extra rule applies. It says we fill these gaps with zeros. And lastly, write 50 to 4 significant figures. In this number, there is only one significant figure, 5. Where do we get the other significant figures? If we put 0, then it makes all the digits significant, including the 0 that was initially not significant. So we have 3 significant figures. To get the fourth, we add another 0 after the decimal, and so we have 50.00. Next, perimeter of plane figures. Now, the perimeter of plane figures is the total length of the sides of the figure. The perimeter of a circle is called the circumference. Any part of the circumference is called an arc. An arc that is less than half the circumference is called a minor arc. An arc that is larger than half the circumference is called a major arc. A line joining any 2 points on the circumference is called a chord. A chord divides a circle into two segments, a minor segment and a major segment. A chord passing through the center divides the circle into two equal halves. It is called a diameter. The distance from the center to any point on the circumference is called the radius, and so diameter is equal to twice the radius. The region enclosed by two radii and an arc is called a sector. The circumference of a circle is given by 2 pi r or pi d because 2r is equal to d, where pi is equal to 22/7 or 3.142. For example, calculate the circumference of a circle of radius 3.5 centimeters. Circumference is equal to 2 pi r, that is 2 times 22/7 times 3.5, and that gives us 22 centimeters. Find the diameter of a circle of circumference 100 centimeters. Circumference is equal to pi d. 3.142 times d is equal to 100. To get d, we divide both sides by 3.142, and that gives us d is equal to 31.83 centimeters. Perimeter of a sector. The shaded region is called a minor sector. It is enclosed by two radii, AO and OB, together with the arc AB. The radii form an angle theta at the center of the circle. Remember, the total angle at a point is 360 degrees. And so the angle theta is a fraction of the 360 degrees at the center. It is given as theta over 360. Equally, the length of arc AB is a fraction of the total circumference, C. It is given as AB over C. The two ratios are equal. AB over C is equal to theta over 360. To find AB, we multiply each side by C, and that gives us AB is equal to theta over 360 times C. Remember, C is equal to 2 pi r, and so in general, arc length is given by theta over 360 times 2 pi r. For example, find the circumference of the sector of a circle of radius 7. Theta in this case is 60 degrees. And so arc length is equal to 60 over 360 times 2 times 22/7 times 7. And that gives us 7.33. This is the length of the curved part. But remember, the two radii are also part of the figure. And so we have 7.33 plus 7 plus 7. And that gives us 21.33 centimeters.
One of the wonderful things about mathematics, I think, is that people are impressed. It's often seen as a very hard subject, and so if you've done math, it's often treated as an entrance requirement, as a credential to do lots of other things. And so one idea is that for example, some MBA programs, the only thing they require going into it is a good, solid math understanding. They can teach you all the business, they just can't teach you the math fast enough. And so I think that math, aside from obvious careers that require math, if you're going to go work in a department that does operations research or something like that, they'll want people with specific skills in mathematics. But math is often seen as as a filter or as a screen for many, many other disciplines. And so I guess what I'm trying to say is you can think broad, because math actually is a solid preparation. It's a good credential to go into lots of different fields that people often don't consider at the beginning.